store files, run apps and files. Now there's other things like Windows and device drivers and security, etc. But the core functionality, store files, run applications on files, and that's exactly what Hadoop is. That's exactly what Hadoop is. The difference is Hadoop does this across many, many, many servers. So Hadoop is, in one sense, you can look at Hadoop as a data operating system. Hadoop is about taking many servers and linking them all together to look like one big system for storing files and running apps on top of these files. That's what Hadoop is. And the two core subsystems are the HDFS and MapReduce. I'm not going to go over those. You guys should have heard about them already. But essentially, it is store files, run apps on files. Now, these are the three key business values, with this one, flexibility, being the key one that makes Hadoop different from existing technologies, which is going to be a theme and a question I'm going to address and try to answer during my presentation, which is how is Hadoop different from relational databases? If I already have a relational database, why do I need Hadoop? How does it augment it, and how is it different from it? Before we jump into that, this is the Hadoop Big Bang, which I alluded to earlier. This is how Hadoop was created. Doug Cutting and Mike Cafarella, which is the other core creator of Hadoop, they were actually working on a project called Nutch, another open source project. The goal of that project, Nutch, was to create an index of the web. Go crawl the web and create an index of the web in a scalable way. So essentially build something like what Google does. They struggled a lot in making it scalable until Google published two papers, the Google File System paper and the MapReduce paper, which then they took and implemented as part of Nutch. So at the beginning, it wasn't called Hadoop. It was just part of the Nutch system. Now, in a separate timeline, in parallel, Yahoo was struggling with their infrastructure. Around 2005, Yahoo was struggling with their infrastructure for Yahoo Search. The infrastructure costs and SLAs were becoming so high that the cost of serving a search request was becoming very close to the revenues from the ads of serving a search request. So, which means it wasn't a viable business anymore. So they needed a new solution. They saw the papers from Google, and they had a choice. The choice was we can go and implement this from scratch, or we can adopt this open source stuff that Doug and the open source community has been working on. And Yahoo decided to adopt the open source stuff for a number of reasons. But one of the reasons that stood out to me, and I was there when this decision was being made, one of the reasons that stood out to me was they looked at this technology, the ability to have this scalable, distributed operating system, as a core power that Google has, that differentiated Google from many others out there, that they had this ability and nobody else had it. So by making it open source, they now neutralize that benefit that Google has. And they enable other companies to be creative, which Yahoo can acquire. In fact, Facebook, as you heard from Jeff, owes a lot of their back-end infrastructure to Hadoop, and a lot of their growth and how they manage data to Hadoop. Yahoo did not acquire them fast enough. That was a mistake, but still, Facebook, like their thesis behind making Hadoop open source was a valid one. Cloudera was founded 4 years ago. So when I and Jeff saw the power and saw how Hadoop solves all these problems, it became very apparent to us that this is more than just a web thing. Not only web companies need this, everybody is going to need this, because these are common problems. Making ETL go faster, everybody needs that. Keeping our data alive so we can continue to extract value from it, everybody wants that. Being able to answer the unknowns and not just the questions and dashboards that we want to answer every week, everybody also needs that. So that's when Cloudera was founded in 2008, a little more than 4 years ago. And we had our first event in 2009, Hadoop World. We had more than 500 people. It was here in New York. Again, 4 years ago, 3.5 years ago. Had 500 people attend that event. This year, we had the same event again. We had almost 3,000 people at the event. So you can see the rate of growth is very impressive. Doug Cutting also joined Cloudera in 2009 as well. So now, this is the core heart of this presentation. I'm going to cover 3 concepts and 3 words that I would like you guys to remember and leave this talk with. And these 3 words are flexibility, scalability, and economic. So now talking about flexibility, which is the core difference between Hadoop and big data systems at large and relational systems. Relational systems, which is the left side of this slide, employ a model that is called schema on write. Schema on write, which means that before you can put any data inside of them, you have to have a schema defined first. Because the database will take that data, will change its format, and convert it to that internal structure that the database maintains. If any new data comes that doesn't follow that model, that is not already in the schema, that data will get dropped on the floor. It will not go in until you amend your schema, amend your ETL logic, and amend your data models on top. And that's both a curse and a blessing. It's a blessing because by doing the schema at write time, when I'm loading my data, I'm able to lay out my data in special ways to make the joins and the interaction with my data extremely fast, to make OLAP a very fast thing, which is a good thing. It's also a blessing because by having a very well-defined schema, I can have a very structured governance process across my organization, so everybody knows exactly what columns are inside that table, which is a good thing. However, I'll tell you from my experience at Yahoo, and many of you might have seen the same thing, whenever I wanted to change one of my core schemas, to add a new column or add a new attribute, if I was lucky, which almost never happened, 2 weeks. In reality, most of the time, to add a new column to any of the core data models, 6 months. Which means by the time we actually had the data in there, the business question that was behind adding that thing was gone at the first place. It was not relevant anymore. Very big issue. So you want to be able to couple and complement this, with schema on read. And that's what makes Hadoop so powerful. Because Hadoop says at write time, when you are giving me data, give me anything. I don't care. Give me a file, XML, a raw dump from Oracle, a raw dump from a mainframe. I don't care. At write time, I don't care. I just handle it like it's a file. And then at read time, that is when I'm going to parse the file and extract the schema that I care about. And each one of us can extract their own schema and their own view. New data can start flowing in. 6 months later, I can change the way I'm doing my extraction, and immediately I will have the full history of that new piece of data without having to redo, reload, etc. So essentially, I'm doing ETL on the fly, essentially. Hence the name schema on read. Clearly, the benefit is agility and flexibility. Now, I'm not held back by the shackles of this schema on write model. But it doesn't mean that we don't need this anymore. We need to have both in our organization. So that's number one. And this is really the core difference. And this is the litmus paper test of telling, is this a big data system or is this somebody just calling themselves big data? You just ask them this question. Do I need to create a schema first before I can put my data in your system? They say yes. You tell them you are a relational database. They say no. You tell them then you're like Hadoop. The number two benefit, which relational databases have, but not at the same scale as Hadoop, is scalability. And scalability here has two dimensions, scalability of machines and scalability of humans. I mentioned earlier that by leveraging local disk more than leveraging the network, we are able to scale much more than before. However, the other key aspect of this is the same queries and the same jobs that the developers write to work with 3 nodes or 4 nodes, literally work on thousands of nodes. You don't need to repartition, you don't need to re-index, you don't need to change your store procedures, etc., etc. So the humans scale as well, not just the machines. Same thing on the administration. Most of our customers can scale up to 1,000 nodes per system admin. 1,000 nodes, including the proprietary software cloudera manager we provide. Now you need 2 system admins in case something happens to the first guy, but still, it's very, very efficient in terms of how much you can scale a human workload. Now, many database vendors will say that we can scale to petabytes and petabytes of data. and other storage systems would make that claim as well, it's important to understand the difference between having a single system with petabytes and petabytes of data versus I have a few terabytes over here, and a few terabytes over here, a few terabytes over there, and then I add them up, and then they are petabytes. Today, Hadoop is the only system proven, not theoretically on paper, but proven in practice, to run with 100 petabytes of data in a single instance. Facebook today has 100 petabytes of data in a single Hadoop instance with 4,000 nodes. Nothing else on the face of the earth that's commercially available is proven to run at this scale. Now, Google internally obviously has something. Microsoft internally has something. Amazon internally has something. But nothing available for enterprise deployment today is proven to scale like this technology can. The third benefit is economics, which is return on byte. Return on byte, very, very fundamental concept. And actually, it's underlying the big data movement and the data science movement in many ways. Return on byte is similar to the definition of return on investment. Return on investment, as you all know very well, is how much value am I getting as a function of the cost of that value. Exactly the same thing. Return on byte is how much value am I getting from the byte as a function of the cost of storing that byte and keeping that byte. And as I alluded earlier, obviously, if the value is less than the cost, meaning you're under the water line here, where are you going to go? You're going to go to the graveyard. I'm not going to see you again. Even though you still have value. You still have value in you. And you have lots of value in you. But I'm still going to send you to the graveyard because I can't justify keeping you. And Hadoop flipped this formula on its head. Hadoop, with CDH, with our complete stack that we provide, brings down the cost of storage, not just storage plus processing, to a few $100 per terabyte, as opposed to 10,000 to 100,000 per terabyte. One order to two orders of magnitude in difference. You need both. You need both. I'm not saying you only need this or only need that, because there are some bytes that have so much high value that they deserve to fly in first class. Right? They deserve to fly in first class. They deserve to get there ahead of everything else because they just have so much value in them. But not all of your data deserves to fly in first class. A lot of your data is okay flying in economy class. And that's kind of what we enable you to do, especially with Impala, the system that Jeff alluded to and provided before. I am running out of time, so now I have to make a decision what to cut. I think it's important to go to this one, so I might do this one and then cut. I'm sorry about that. I just want to go a bit slower because it was important to get these 3-4 concepts, because really these are the 3 keywords I want you guys to leave with: flexibility, scalability, and economics. Nothing out there matches what we can offer. This is CDH, which is our big data platform that we offer to you. You can see that Hadoop is just one block in this nice complex figure. Hadoop is just one block, and that's the core message of this slide. Hadoop is simply the kernel of this operating system. In the same way that if you go and you want to get Linux, you don't go to kernel.org and just grab the Linux kernel. You go to Red Hat, because you don't want just the Linux kernel. You want the Linux kernel, you want the device drivers, you want the security models, you want the X Windows UI, you want the Apache web server, etc., etc. You want all the elements that make it